we're going to graph some slope fields, and this is fascinating. This is pretty cool. You basically have a collection of all of the tangent lines at a particular location. And you might look at this and think that you have to figure out and calculate each line, but you don't. It all depends on the kind of curve or the equation that you have. Some are easier than others, right? But this one, what I'm going to do is, you guys can read this on your own, but I'm going to kind of cut to the heart here. If I have a dy dx equals y, we know that the original function is going to have a plus c, right? So we know that there's families here that we're actually graphing. And so when we have a differential equation, the graph of it looks like an equation it looks like a bunch of slopes, okay? So what we do is to graph these, okay? They're actually they're kind of cool when they're simple. You can just kind of plug in a number and see where it takes you. Now notice that this is dy dx, so it is a slope and it equals y. So let's pretend that y is 1, okay? The y is 1. So if the y is 1, I do not have an x coordinate associated. There's no room for me to put an x coordinate into this equation. Now here, this is just an x, there's no y. But over here, I actually have both. I have an x and a y. When you only have one variable, these guys are actually pretty easy to graph. When you have two of them, it takes a little bit more work, and we'll get into that. But if we only have one variable, either the x or either the y, these make for kind of quick graphs. I'll show you. So let's assume that this is 1, okay? When y is 1. So when y is 1, right here, okay, this means then that my dy dx is also 1, okay? So that means that at 1, my slope is 1. So you will see here roughly at 1, do you guys notice that my slope is 1 right there? Now because I don't have an x coordinate, it doesn't matter. If my x is 1, it doesn't matter. My y is 1. My y is 1. My y going all the way across, my slope is 1 for the entire span, okay? If my y is 2, you will notice that this slope increased from a slope of 1 to a slope of 2, okay? So these slopes didn't just come out of anywhere. They come directly from how this got, what the value you plug in for the y or the x coordinate, okay? In this case, we don't have any x coordinates. So whatever our y is, that is the slope, okay? This right here is going to be a slope of 1.5, okay, roughly, okay? What about here when y equals 0? The reason why you don't see it is because all of these slopes are actually 0, okay? Those are slopes of 0. And likewise, right here, it just switched. When the slope became negative, you'll notice that these are all -1/2. This is actually -1. This is -1.5, and this is like roughly -2, okay? So these guys represent, we just went straight across because our x coordinate is actually not there. It doesn't matter. It's just kind of a blanket graph, okay? So you can see here that when y is 2, the rate there is actually 2. Okay, it's steep, and that's sometimes all that you have to know. You just have to know if it's really steep, if it's halfway there, if it's flat, or if it's negative. Sometimes that's all that people really care about, is it increasing or decreasing at that particular point. Okay, so now let's go ahead and say, what if it's a little bit more complicated? Let's say we got a 3x minus 2. What we'll do is we don't have an actual y input for us to put in coordinate. So what we do is we just focus on the x, okay? Now I have x coordinates of -2, -1, 0, 1, and 2, so I'm going to go ahead and do that. -2, -1, 0, 1, and 2. Those are the guys I'm going to plug in, okay? Just because that's kind of what I have available for my graph, okay? Now if I plug this in, okay, -2, -2 is going to go in here, okay? So 3, -2 minus 2, that's going to give me that's -8, okay? That's going to be a -8. So this means when x equals -2, okay, I have a very steep slope of -8. It doesn't matter what my y coordinate is. because I'm going to go straight up all of the x's that are -2, and I'm going to have a really steep -8 slope. Okay. Over here at -1, let's plug in a -1. That's going to be -5. Okay, steep, but not that steep. So it's going to look maybe something like this. Okay. What happens when x is 0? Well, slope is -2. Okay, because 3 times 0 is 0 minus 2 is -2. So that's going to be -2. That's maybe something like this. Okay, so you can see how quick, this is actually a quick process if there's only one of the variables. When I plug in a 2, I get 1, I'm sorry, plug in a 1, I get 1. So now it just went positive. And 1 is just a diagonal, right? He's the diagonal line. And then I plug in a 2, I get 4. Okay, so this guy gets a little steeper. Okay, and that's it. That's the graph of the slope field. Now, I don't know if you can kind of tell, but what would be the antiderivative of this guy? We can actually, let's calculate that, okay? Let's take the antiderivative of this guy. All right, so dy, and then we're going to multiply by dx, okay, if you remember earlier yesterday. And then I'm going to take the integral, okay, and what I get is I get y, and then that's going to be the integral of 3x minus 2. That's going to be, let's see, that would be 3 over 2x squared minus 2x plus c, okay? Now, that's a quadratic. Can you see the quadratic formed here? Can you kind of see? Do you guys notice that this guy's negative, but then this guy's positive? So my guess is that the axis of symmetry here is going to be right there in the middle because that's where it switched its direction, okay? So what I want to do is I do want to take the time to actually check that out. So let me grab that. I think I had my slope field thing here. Okay, let's move this out of the way here. Okay, and we're going to do, let's type this in so we can see it. We got 3x minus 2. Okay, that is actually, all right. Now you can see here that we actually, our density, our graph kind of is like kind of like that. 1 and 0. Yeah, kind of like that, right? All right. But if we increase the density, we'll notice you can kind of see that's really clear that in between 0 and 1 is where we're going to get our vertex, where they kind of converge, and you can see that on your paper, okay? And what we can do also is put in some solutions here, and you'll notice that these solutions are kind of part of that family. Let me zoom in just a little bit there. All right, so that's it. That is a slope field. It basically, if you're only dealing with rates, this is what a graph of those rates has to look like, okay? All right, going back to here, let's graph this one and then we'll stop this particular video. All right, so now what if we have two outputs here? Or I should say two inputs. We got an x and a y. So I'm going to go ahead and solve for this guy. Let's go dy dx equals, we're going to put the 2x over to the other side, and then we're going to divide by -y. That's 2x divided by y. Okay, now what this allows me to do is it allows me to kind of, now I've got two channels for me to put my coordinates in, okay? And so what I got to do is I could fill in each one of these, but I might be able to detect a pattern here, okay? So I'm going to go ahead and, I don't know, let's just pick the outer extreme here. Let's go -2, okay? And let's just go ahead and do a y coordinate of 2, okay? So we're picking this dot right there, -2, 2. So if I plug these guys into here, I'm going to get a number. It's going to be, let's see, -4 divided by +2 is -2. Okay, so -2 means that right here I have a slope of about -2. Okay, it's a -2-ish. Okay, what about going down? Okay, let's just go down. Because my y-coordinate has changed, I actually am going to have a change here as well. So here, as we're graphing a slope field, is kind of a little bit more time consuming, okay? But the idea here is if you do it once, you can, when you get to something like this in matching, you can kind of pick out the slopes that you're interested in, and you can use the process of elimination to figure out what it has to be, okay? So we'll do this one carefully, and you can make your table as big as you want, but I'm going to go right here. I'm going to go -2. -2, that's -4, divided by 1 is actually -4. Okay, so that's going to be even steeper. Okay, and then here when I get to -2 and then y is 0, that's going to be a DNE, because I would be dividing by -4 divided by 0 is actually doesn't exist. Okay, so we don't mark anything, but we're still going to go down. How about -1? -2, -1. -2, -4 divided by -1 is +4. So then this guy all of a sudden jumped to some steepness right there. Okay, and then we've got -2, and we'll go -2. That's this location. That's 2 divided by -2. That actually gives me +2. Okay, +2. So he's going to be maybe about that. Okay. All right. Now, then what I do is then I would go to -1. Okay, and you can do these mentally if you want. Okay, but I think what you'll notice is that if I have one, let's just try one, -1. -1 would be -2, and then +2, -2 divided by +2 is -1. Oh, sorry, calculate it. Divided by +2. I'm writing these numbers in the wrong location. Okay. Oh, 12 minutes already. Dang, these things go by so fast. I picked this point right here, -1, +2. It's actually going to be -1. Okay, so that's cut that guy in half. Okay, so you guys then maybe you can pick up that if I put a negative, man, I misspoke, didn't I? Yeah, no, I'm good. That's why I did it in pencil. I knew that this was going to be an issue. There's so much going on, like you can really lose your track. So -1, +2, it's going to give me -1. So that's good. Next, we got -1, and then we're going to go +1, -1, -2 divided by -2. Okay, and I don't know if you guys noticed, but it's basically going half of this. Okay. So -2, a little steeper. And then again, when we get to 0, it'll be undefined. Okay, so this guy, all these y = 0s are going to be blank, period. Okay, let's see what happens when we have, oh wait, what about this though? -1 for -1, and y is -1. -1, -2, that's going to be, that's a +1. Okay, and then this guy, the next one here would be -1, -2, -1. That would be a -1, 2. That's also +1, right? Or my brain is -1. No, I'm sorry. This should be +2. A little steeper. Okay, a little steeper. Okay, so that should be a +2. That's a -1. +1. Okay, so you can kind of see this formation here, and what happens if x is 0? If the x coordinate is 0, you'll notice then that all of these guys are going to be flat lines. So that was easy. Okay. Now, if x is positive 1, you might kind of notice that all that's happened is that these guys are just going to switch their orientation. Okay. So if it's positive 1 over here, then you're going to end up with that. And what I'm doing here is I'm just mirroring these. Okay. And again, these are just sketches. I ran out of the table, so now at this point, I'm literally just trying to figure this. Just mirroring these guys. Okay. Okay. So these guys, just because when we are now switching our x's to be positive, these guys will just completely switch their slopes. Okay. So the point is, there are patterns to these that you just have to. You'll get good at this through experience. We're not going to have a lot of experience with these. It's a relatively minor topic because, like I said, these are more analyzed in topic 4. Okay. All right. So we'll do the next topic.